Science Academy, the science provider of the nation.
Hi everyone. Today we are going to study about ST and VT graph. ST and VT graph. I think so you went through the lecture on graph, the linear graphs. It is on the playlist. Go and check. If you are not thorough in that portion, I don't think so that you will be able to go through this part, because here we study we use all the fundamental things what we study on graph in your grade 9. So however, a graph means the graphical illustration of a data. When there is a complex data, a graph will make it simple and make us understand very simply. So here there are two types of graph in physics, that is, one is ST graph and the second one is VT graph. So first of all, I just go through the portion of graph. So graph has two axes, one is y axis and the second one is x axis. Okay, so everyone they start at 0, plus 1 this side, and this side will be negative value, and upper portion will be positive again in y, and here it will be negative, right? So here what happens is a gradient. We have studied in the linear graph. We study about the equation y is equal to mx plus c graph usually. So here the m means we call it the gradient. And c means it is intersection. So gradient means it defines the slope of graph. So here if I use the term graph, you should not think about x and y. Graph means the line drawn in between it. So here this is the graph. So if I say you that the gradient of graph, you should think only about it. So the gradient of graph will define the slope of graph. So this is the graph and slope, how much it is slanted toward x or y. The gradient means it defines the slope of graph. So here the gradient of this graph and the gradient of this graph are not equal, because the slopes are different. So slope is defined by the gradient. That is one of the main important point. So if I draw a graph like this, a curved graph, here what's happening, the gradient is not constant. The gradient is varying. Okay, so if there is a constant gradient, the graph will be a straight line. Either it is negative or positive. So I think so if you study the lecture on graph, you will be capable to understand how the positive gradient come, how the negative gradient come, and how to identify, how to calculate the gradient, what is intersection. So intersection means where the position where graph meet y. So here this is the graph and it meets y at this point. So the intersection is 0. So if I draw something like this, here this is the graph and here it intercepts y at this position. Okay, so here this is the intersection. The gradient is going to be the slant. It defines the slant. So however, please go and check in that lecture what is gradient and what is intercept. Otherwise, you will not be able to understand or go through, identify what are they saying, what I am teaching in this lecture. Right. So before going to the portion, let's study, that is ST graph. So in ST graph, you might have studied in several methods. Okay, some people, most of the students are trained to by heart this portion. That means some of them have studied that there are 12 types of ST and VT graph. It is totally wrong. ST and VT graph can be drawn for any situation it's happening in our physical environment. For example, if I walk, even the motion of walk, I can draw an ST or VT graph. So here ST and VT graph is not a portion to by heart, it is actually a portion to derive and understand what is there. So here I will give you questions. I will give you questions based on two different types. First, I will give you data and I will ask you to draw diagram. So before that, if you think of ST graph, the y-axis means the displacement. ST graph means displacement time graph. And the x-axis determine the time taken. So typically we measure this displacement in meters, this SI unit. So the time is in second. The time is in second. So here what's happening is, in a history graph, if they give you a data like this, they give you the displacement and the time. So at 0th second, at 0th time, the displacement is 0. After 1 second, 3 meters made. After 2 seconds, 6. After 3 seconds, 9. After 4 seconds, 12. After 5 seconds, 15. So this is a complex data. It is not easy to understand. So now what I am doing is, I am collecting this data and making it coordinates and going for a graph. So here time should be in x-axis and displacement should be in y-axis. So what I am doing, if I draw the coordinates, you know how to write coordinates. Whenever you draw the coordinates or write the coordinates, x value should be first and y value should be second. So if you write them here, 0, 0, 1, 3, 1, 3, 2, 6, 3, 9, 4, 12, and 5, 15. So these are the gradient pairs, so coordinates. Based on these coordinates, now you should draw the diagram. So if you draw the value, so however you know that whenever in an axis, the gap should be equal. So what I am doing is, I am giving 0 here, and the time 1, 2, 3, the gap should be equal 4, 5, 6, 7, it's continuing. And here I make it easy. This gap is equal to 3. The same gap 6, 9, 12, 15. Right. Now what I should do is, based on this, I have to mark these coordinates on the graph. So if I draw the coordinates, first 1, 3, here the coordinate. The second 2, 6. 2, 6. Third one 3, 9. Fourth one 4, 12, and fifth one 15. So if I draw it properly, it will be a straight line. So here they have given you a complex data, and it is simply illustrated by a graph. So this is the ST graph of this motion. So what they say is, at 0th second, it is at the 0th position, at the initial position. After 1 second, it went 3 meters. After 2 seconds, it went 6 meters. After 3 seconds, it went 9, 4, 12, 5, 15. They have given you this data. We have drawn it in a proper manner. Right. So now in ST graph, I am coming to the point. What are the data we can derive from the ST graph? So the first thing, these are the node points. The first thing, in ST graph, the y-axis determines the displacement. Y determines the displacement. X determines the time. So if they ask you, based on this graph, what is the displacement at 5th second, you can go to the graph. 5th second, go to the graph, draw a straight line, keep a foot rule and draw a straight line, and at 5th second find the value in the y-axis. So what is the y-axis? 15. At 5th second, it is at 15th meter. So these are the data. So y gives you the displacement, x gives you the time. If they ask you what is the time at 10th second, what is the time when the object has 10 meter, when the displacement is 10 meter. Now the question is what is the time when the displacement is 10 meter, right? So here we know that 3 is there, 6 is there, 9 is there, nothing. But 12 is there. What you can do? You can divide them into 3. 9, 10, 11, 12. So at this position, you should find the time taken. So what you can do? Again draw the diagram, graph, and find the value and come down. So here it's going to be about ultimately if you calculate in a very proper manner, you will be able to identify. Here it is about 3.3 seconds. So what we are doing is, based on a graph, we are collecting the data. The data are very complex whenever you see, but here it has been made into a simple format and we are making it to the graph. So the first detail, y gives you the displacement, x gives you the time. And the third point, gradient of graph gives you the velocity. This is the most important point. Gradient of graph gives you the velocity. Right, how we can calculate it? So here they have given you a graph. How to calculate the gradient? It is there in your grade 9. Go and refer. If not, you can't do this. So however, if you find the gradient, what you should do is, you have to take two coordinates. You should take two coordinates, subtract one from another. Subtract one from another. So what I am doing is, I am selecting two gradients. This is one gradient and this is, I am selecting two coordinates. I am selecting two coordinates. Here the coordinate is 5, 15. 5 and 15 is the coordinate here. Here the coordinate is 2, 3. So the x value is here. This is the x value, x1, and this is y1. This is x2 and this is y2. So what you should do is, the difference of y value should be divided by the difference of x value. You have studied the gradient is equal to y over m. It means the difference of y divided by the difference of m. The difference, that is the most important thing. It is not, you can't say y divided by m. It should be the difference of y value should be divided by the difference of x value. Difference of x value. So here what I am doing is, the difference y1 minus y2 divided by x2 minus x1. X1 minus x2. If you divide them, if you get the value, here what's up, it's a very simple thing. 15 minus 3 divided by 5 minus 2. So the x2 value is 1, right? Yeah. So this is a 2, 6. Here it is 2, 6. Sorry, I have committed a mistake. The x2 value is 2, 6. 2, 6. Okay. So if it is 2, 6, 15 minus 6 divided by 5 minus 2. Here the answer will be 9 divided by 3. The answer is 3. The answer is 3. Right. So if you think of it, here what you are doing is, you are dividing. If you consider about the y value, y is measured in meter. Y is measured in meters. Y is measured in meters. And the x is measured in second. So the answer, if you take it up, meter per second. So meter per second means it is velocity. So here the third point, gradient gives you the velocity. So in ST graph, there are three main points. Y gives you the displacement, x gives you the time, and the gradient gives you the velocity. So here what you can say is, the velocity is a constant value. Why? The gradient is a constant value. As the graph is a straight line, the gradient should be constant. When the gradient is constant, the velocity should be constant. So the simple graph gives you such messages. Let's come to another point. Another question or another example. So they have given you a very simple graph like this. They have given you a usual graph. Most of the time, they usually give you the graph and ask you a question. Whenever they give you the graph, always you should answer based on the graph, because that is the expected answers of them. Right, here it is an ST graph. So S measured in meters, here time measured in seconds. Here time measured in seconds. Right? So now what I am doing is, I want to mark them and just giving you the values. So here it is 0, 0. And here it is 5 seconds. It has gone about 10 meters. And then again the same 10. Here it is about 10. And then again 15. Right. So this is the graph what they have given. Now I need to collect the data. I need to collect the entire data. Okay, what this graph illustrate to me. So what I am going to do is, I am just going to think of the theory what I studied. We studied that first point. We studied the first point, that y gives the displacement. Second point, we studied that x gives the time taken. And third, we studied in ST graph, we studied that gradient gives us the velocity. So these are the three main points what we studied. Now our task is to get the entire idea what is given inside it. So what we can do is based on all this stuff, the first thing, based on these 2 points, we can say what's happening for each and every second. Right. At 0th second, at the initial of time, where the object is at 0. That means at the initial point. Okay, this is the first data. And the second, after 5 seconds. After 5 seconds, it is at 10 meter. It is positive 10. It is at 10 meter away. Right? After 10 seconds, it is again at the same position. 10 meter. It is 10 meter away. Okay? So, after 15 seconds, if you consider 15 seconds, it is again at 0. That means at the initial point. So what has happened is, initially, if this is the initial point, at 0 second the object was here. If I take, this is my positive, the right side is my positive, at initial point. After 5 seconds, it has moved. After 5 seconds, it has moved for 10 meters. After 10 seconds, it is at this exact point. 5 meter and again 10 seconds. Whenever I check at 10 seconds, it is at the exact point. That means from 5 to 10 seconds, it has not moved. Right. And after 15 seconds, it is at the initial point. Now what has happened? At 0th point, at 0, it is at the initial point. It has moved for 10 meters after 5 seconds. From 5 to 10 seconds, it is at the same place. From 10 to 15 seconds, it has returned to the initial point. Right. So this is what we obtained by using these two data theories. Right. Now what we can say about this velocity? Let's say, now you can see clearly there are 3 portions in graph. If you can, this is the graph, there are 3 portions. This is the first portion, and this is the second portion, and this is the third portion. If you measure the gradients of them properly, right, I am doing, first I am calculating the gradient of 0 to 5 seconds. Gradient 0 to 5. So what I should do, I have to take 2 coordinates. I should select 2 coordinates, subtract one from another, and divide y value from x value. The difference of y value and x value. So what I am doing here, if I take the 2 coordinates are, the first one is 5, 10. And the second coordinate is 0, 0. If I subtract one from another, 10 minus 0 is 10 and 5 minus 0 is 5. So this is the difference of y, this is the difference of x. So if I find the value, 10 divided by 5 is 2. So you can say from 0 to 5 seconds, it has moved with a velocity of 2 meter second minus 1. This is a message what you derive. And secondly, what you can find is gradient from 5 to 10. Gradient from 5 to 10 seconds. So again, this is the 5 to 10 second portion. You have to select two gradients. So 2 coordinates. So 2 coordinates, first one is 5, 10. 5, 10 is a gradient. And second I am selecting 10, 10. 10, 10. So if I subtract one from another, 10 minus 10, 0, 5 minus 10, minus 5. So if I find it, gradient is equal to y minus y divided by x. Here it will be 0 divided by minus x, the value will be 0. If the velocity is 0 meter second minus 1, what is mean? The velocity is 0 means the object is at rest. What is the meaning of it? The object at rest. So here we can say that object moves with the velocity of 2 meter per second. Right? And the third portion. Now something difficult. Third portion. Again what I am doing? Third portion, I am doing it here. Okay. Third portion. What I am doing is, I am taking the gradient. So the same thing. So the gradient of 10 to 15. I am taking two coordinates. The first coordinate is 10, 10. And the second coordinate is 15, 0. Right? 15, 0 and 10, 10. If I subtract one from another, 10 minus 0 is 10. 10 minus 15 is minus 5. Okay. So, if I get the gradient value, it will be 10 divided by minus 5. It said that minus 2 meter second minus 1 will be the velocity. So, here we got 2 meter second minus 1. Here we get minus 2 meter second minus 1. So, what is the meaning? We thought that right side is the positive. So, from 0 to 5, the object moved in right side in 2 meter second minus 1 velocity. But from 10 to 15, the object is moving in our opposite direction. It is not moving in our considered direction. It is moving in the opposite direction. It is moving this side. Oh, silly. So, look after the graph. The message is what graph gives us. Initially, it gives that we think how we are going. We know that there are 3 points in ST graph. This is what I say is, what you can do is, if you take these 3 points on your mind, you can derive whatever the graph and what's happening, you can say it. Okay, so there is another point which is not in your book, that just to identify, capture the idea of ST graph. Always remember, whenever the graph, so this is the graph, whenever the graph meet x-axis, so here it is meeting, here it is meeting again. The meaning of it is coming to the initial point. So write that point as fourth. It's not in your book, I'm just giving it. When graph meets x-axis, it crosses the initial point. Okay, or it comes to the initial point. So here it has met, the graph has met. So the meaning of it is what? It has come to the arrive to the initial point. Here again it has arrived to the initial point. So these are the data can be derived in an ST graph. So next we'll go to the VT graph portion.
Science Academy, the science provider of the nation.